Hello, teacher and gentlemen. Here we are again. My name is Rafael de la Mora.
And my name is Vladimir Leonardo del Mar Bascuñán.
And we are going to talk about the derivative of a
Function.
That's true. You are going to be seeing how we solve a function with your previously knowledge, the way you taught us in the classroom.
Yeah, we're from Pipe Angelopolis, if you don't remember.
Of course you remember because you're great.
We are going to demonstrate the rules you have and formulas you have previously taught us, as Ferran said.
Yeah, that's true. So, let's start with this.
Yeah, boy, we're going to start with functions, mate.
And first of all, we're going to start with the derivative of the constant. We are going to start writing the function of x. It's equal to the limitant that tends to be 0 of the function times x plus change of x minus function of x divided into the change of x. This is equal to the limitant that tends to be 0 c minus c divided into the change of x. This is equal to the limitant of 0 because c minus c in this case is equal to c and the derivative is equal to 0. So doing this is 1 minus 1 that is equal to 0. Between this that is 0, it's equal to 0. So the limitant of 0 is equal to 0.
We're going to start now with the demonstration of the division in a function. So the formula is the one from below. Well, you just have to wait for me for a little bit because I'm a little bit slow. So this is the expression to derivate the equation. Well, not the equation, the function. Sorry, bro. Sorry, mate. Sorry, teacher. Sorry, Jesus. So this is how it goes. What does this mean? Okay, the one from below to the derivative from the top to the top as it is, and the derivative from below divided between the one from below to the square. Now, in order to put this expression in the definition of the derivative, we need to substitute the needed values. So this is how it is going to be. We know that there is a common expression of the straight line. So yeah, we're going to put that between delta dx. You all know how it goes. When delta dx tends to 0, and in here we require some algebraic forms to get the expression, because we factorize this so we can get the needed expression, and it will be something like this. Now every time this is going to get a little bit more complex, but it's all algebraic forms so it won't be such a mess to deal with him. So yeah, we are still going to do some algebra in the coolest possible way, because that's how we roll. Now, you may ask, what am I doing here? And I'm going to tell you, wait, we're going to have some patience. Now we need to still express this, so we're going to rush more this time because it is going to be a lot of procedures. we need to take load on. Oh. So we did a little transition because in order to write all of this, it required a lot of time, and we need to do this quickly as possible, you know. So then how did we get from here to here? Well, we just kind of factorized this, and as you can see, what Newton did in the beginning is that he provoked this to be a minus and this a positive in order to be the same expression as the last one and be like in the same rules of the functions. Then we happen to here applying the limits, so we apply this in a sandwich way. There's some algebra in it, so as you can see in the next one we apply the limits inside these functions, and all of this is dividing the same expression, but this time with the limits inside. So we know these facts of limits as rules, and then we apply it in this same expression, and it will have the expression we wanted it to have. Why? Because that's how we did it. We factorized this, we canceled some procedures, and because if we were to do it in the normal way, we will get it. So that's how. So we hope that this video is helpful to you guys, because this video is going to be on YouTube, on the network, and you can see how we applied some Newton theories and, well, no, theorems, and it was made with the rules.
Hope you enjoy it.
It was a fun project. Yeah, a fun project. See you guys
Next time.
We love you.
Buenas a todos.
Hey guys, this is Dad and Ferran. We're going to present derivatives.
Hello, teachers.